Today we're going to be performing a regression analysis. Now we're going to do a whole regression analysis here. Now what are the elements of a regression analysis? First of all, we're going to be looking at the scatter plot, and we're going to work out if it's a negative or a positive and whether there is a linear association. Now remember, if there's a pattern, there could be no linear association. We're going to be looking at the correlation coefficient, the R, determining whether it's strong, moderate, or weak, or of course no relationship. We're going to be finding the equation of the line. Okay, remember, the one next to the x is always the gradient, our slope. We might need to interpret that. So if we're interpreting that, we always use the words on average. And we have to talk about for every one. Now it's got to be a unit of measurement, whether it's centimeters, meters, seconds, minute, whatever it is, for every one that is increasing, because x always increases. That's increasing the explanatory variable. The response variable, now whatever this response variable is, that's the y. Now if it's a positive gradient, it's going to increase. If it's a negative gradient, it's going to decrease by whatever this gradient is. So we're looking at the rate at which the data is increasing or decreasing. We might be looking at the y-intercept. Now the y-intercept, remember, it's when the x value equals 0. So we have to check on our axis and make sure that this point here is actually at 0. If it's not, then we can't say that that's the y-axis, because if that's 10, then when we extend it at x equals 0, that's where it really matters. Okay, but if they ask us to interpret it, that's what we're doing, estimating the average value of the response variable, which is the y, when this explanatory variable equals 0. Okay, has to be equal to 0. We can make predictions. How do we make predictions again? We substituted the x value into our equation and we find our y values. If we're finding the values that are within the range of data that they give us, then we are interpolating. If we're finding or using values that are outside the data range and we're trying to find the prediction, we are extrapolating. We can find coefficient of determination as well. Remember, we just square the R, and this gives us a measure of the predictive power of the relationship. When we're finding the residual, which is actual minus the predicted value, okay, if we get a positive, then we know that the data points are above the regression line. If we get a negative, then it's below, and if we get a 0, then it's on the line itself. Okay, and the residual plot tests the linear assumption by plotting the residuals against the V. And here we go, we have to see no clear pattern in a residual plot. Okay, if we see no clear pattern, okay, then it confirms it. If it's, scattered around, then it still confirms it. If we see a pattern, now we're talking about a pattern that's obvious, then we can't confirm that it is a linear assumption. A residual plot that shows a clear pattern like this is not linear. Okay, not linear. Suggests, okay, very important. Okay, this suggests a non-linear assumption. Now, it doesn't have to be this clear of the pattern, but it's got to have a pattern. Of course, we can do all this on the calculator. Okay, so if we've got the data here, birth rate, life expectancy, we can put this in. You just need to be careful which one's your X and which one's your Y. So read the thing properly, all right, the information properly. Normally, if you can't distinguish, the X is the first one and the Y is the second one. Make sure you label your axes or your data when you put it in. Sometimes look ahead in the exam. They might have it already done, so you can see this is always the explanatory, and this is always the X, and this is always the response, which is your Y. And then we can do our line of best fit, the least squares regression line on the calculator, and we can see it. It gives us the R squared as well if we've got our information on. we don't write it in terms of X and Y. We should write, instead of X, we should write birth, and instead of Y, we should write life expectancy. So we need to make sure that we convert it properly. And then we do our residual, and all the information of how to do it is there. I'm not going to show you how to do that. And you can see that the residual, this one here, shows no clear pattern, and therefore we can confirm the assumption of linearity with this residual plot. Okay, example 1. Use the lines on the graphs to determine the equation of the regression lines shown. Okay, so here, if they give you the line, you have to work it out, of course. Now, choose 2 points that you can see. So I would be choosing here 7 and 50 because I can see that point very, very clearly. So I'm just going to make it bigger. And I'll choose 0 and 80. So 7 and 50 and 0 and 80. So I already know my y-intercept because I can see that x equals 0 here. So, oops, that should be an 80. Okay, so y I've already got, so I'm going to just work out my gradient, which is, remember, y2 minus y1, so 80 minus 50 divided by 0 minus 7. So when I work that out, I get negative 30 on 7, and it should be a negative because my line goes downhill, and downhill means negative. So this rule here is just going to be y equals, now y is mark, so I'm going to be writing as mark, equals mx plus c. That's the rule we use, y equals mx plus c. That's what we're always used to. The calculator will have different rules, but it doesn't matter. So the m here times the x, days absent, plus 80, my y-intercept. For the second one, I'm going to use 15 and 8 because I can clearly see that one crossing the lines, and I can make that point out. And I'm also going to use 30 and 14 because I can see that. So working out my gradient here, 14 minus 8 and 30 minus 15 is going to give me 6 on 15. Simplify that, 2 out of 5 because 3 goes into both of them. So far I've got y equals 2/5 x plus c. I can use any one of these points to find my c. I'm going to use 15 and 8. I cannot read c, the y-intercept, off the graph because the x here is 10, not 0. So I'm using that one there, so I get 8 equals 2/5 times 15 plus c. So I get c equals, when I work it out, c equals to 2. And therefore my rule, and I'm going to write it in terms of the data that they give us. So death rate, I'm just going to put dr, death rate equals m, my gradient, 2/5 times my x, which is birth rate, r, plus my c, which is 2. And this is a positive gradient, and yes, I've got a positive gradient, just to confirm all that. Example 2 says use the data set given to answer the questions below. So there's my data, and I've done this scatter plot on the calculator, and I've just pasted it in. So there's the scatter plot. You can see I labeled this hours studied down here, hours of study, and this is the result. So there's my x and there's my y. Okay, find the equation of the least squares regression line along with r and r squared. So I found my equation, and there it is there. I can quickly see it. Okay, but this time I'm going to write it in terms of the variables. So final exam result, and it doesn't say anything about decimal places or anything. I'm going to go to 2 here, 42.37. Now it is 17, but 42.37 plus to 2 decimal places, 5.31 to 2 decimal places as hours studied. The r squared gives it to me. The r squared is 0.887942. Now it says r as well, so I'll square root this, 0.887942. Now remember, when you square root, you take positive or negative. I only want the positive because this is a positive graph. Okay, if it was down like this, I'll be taking the negative. So positive graph only, so I'm just doing the positive, so I get 0.9423. Okay, display the regression line on the scatter plot. It's already there. Part D, the actual exam result for 3 hours study is 68%. Calculate the residual. Okay, so the residual, when I do that, remember the residual is actual minus the predicted. The predicted, we're doing it from the equation. Okay, the actual result is 68%. There it is there. The predicted, well, if I put in for that one there in the rule, I'm going to get 42.37. Now you can do this separate, plus 5.31 times 3 hours of study. And when I work that out, I get 9.7. So there is my residual value. Don't round off for your residual value. Part E, fill in the missing numbers in the table. Now, I've filled most of these in. I always had the X and Y for students and then did all the rest except one Y where it's equal to 2. So this is the Y value when X equals 2. So if we go back up, when X equals 2, we get our Y value. It is 50. So that's what I'm writing in there. The information is already there. So I'm putting 50 in here. Okay. The predicted value, of course, I'm going to use the line. So I'll get, to work out that one there, 42.37 plus 5.31 times 2. And when I do that, I get 52.99. So that's what's going in there, 52.99. The residual, I'm just taking away the 2. So the residual here is the actual minus the predicted. So when I do that, I get negative 2.99. And for this one here, the actual, which is 42 minus the predicted of 42.37, gives me negative 0.37. Okay. Construct a residual plot. Again, just on calculator, construct a residual plot. Look, no clear pattern. So this supports the assumption of linearity. That's what we decided. Part G, predict the result of a student who studied 4.5 hours. Okay, 4.5 hours, I'm going to put it straight into there. So the result predicted, remember, use the line, 42.37 plus 5.31 times hours of study, 4.5. We predict that this person will get 66.265. I haven't rounded here. Okay. What type of prediction is this? Well, 4.5 hours, that's inside the data range, so we're talking about interpolation. That's what type it is. H, how many hours of study were engaged by a student, gaining a final result of 60%? Well, there's the rule. So this time they got 60. So 60 equals 42.37 plus 5.31 times hours of study. So when we work out our hours, and you can just solve on your calculator, or you can do it mathematically, take away the 42 because it's a plus here, and then divide by the 5.31 because it's a times there, and you can get that answer. But if you do it, and solve on your calculator, it's not a problem. You end up getting 3.3 hours. Okay, so that's fine, not an issue. Part I, comment on the prediction or result of the person who averaged 20 hours of study. Okay, so the final result of 20 hours of study is 42.37 plus 5.31 times 20. And when we work that one out, you don't need solve here because you're not finding anything. You're just putting this into your calculator. There's no letter there. Okay, when you work that out, you get 148.57%. Now this is impossible. How can you get something bigger than 100%? So absolutely impossible. I mean, we might need to be asked to write a report. It says from the scatter plot we see that there is a, now if we go back up to the scatter plot, which is up here, look, that's strong. So we're going to say strong. Strong. And we're going to say it's already strong there. Linear association between the exam result and hours of study. Hours studied. With R equaling, and when we worked out R, it was 0.9423. No obvious outliers. The equation of the least squares regression line is, we worked it out, it was result equals 42.37 plus 5.31 hours studied. The slope of the regression line predicts that on average the exam result, this is the slope is the 5.31. So the exam result is going to, it's a positive here, so increase by 5.31 because the result is in percentage for every hour in study. Intercept of the regression line, so this is the y, which is 42.37 here. So it predicts that on average exam result with no study is 42.37%. That's what we would expect them to get if they do no hours of study. Coefficient of determination indicates that this is your R squared. Now your R squared was 0.88. Now we want it as a percentage, so it's 88.79% of the variation in, and we always use the X there, variation in, the Y's, hours studied, result, the Y, result, in the result can be explained by hours of study. Okay, select the correct statement. The residual plot shows a pattern, or the residual shows lack of a pattern. That's the right one, that's the wrong one. Okay, so that brings us to the end of 4C and 4D.